Hello, and we are back. It's Jared here with another episode. We have a Retreat Hamilton in the workshop, lithium battery conversion, full Victron system installed, solar upgrade, all the good stuff. The van came to us with just 2 AGM batteries mounted in the chassis boxes. Now we have upgraded the 2 batteries in here to IP67 200 amp hour lithium batteries with our shunt is external and the batteries, the blue light that you can see is the batteries on off button. The Anderson plug at the front of the van just went directly to the batteries, so the old setup was just an isolator setup on the car. Now we've got it running to a Victron 50 amp DC charger, which I'll show you shortly. We'll walk in, you'll see Victron screen, happy days. 2 under the bed, and this is where all the magic has been done. Simple setup, like in theory, but it's just such a good and easy setup to be able to go fully off the grid, have plenty of solar coming in, have plenty of DC charge coming in, have a full monitoring system for it, and allow for expansion down the track if needed. So you've obviously got your servo up there, which is looking after the screen, 50 amp solar. I'll show you what we've done with the solar on the roof in a second. Solar main switch circuit breaker there. And we've got an Orion 50 amp DC charger. So that now we've run a new 16mm twin cable from the charger. The fuse here does the input, so between the charger and the Anderson plug on the front of the van. And then we've also got a fuse panel underneath that does both the DC charger output and the solar output. And then we've got 2 spare fuses there for expansion in the future. 3 kVA multi-plus, 120 amp battery charger, pretty standard for what we do. The customer did have those 2 little cables there. Had a little inverter here running a power point here, which wasn't double pole, so we've swapped that out to double pole and also hooked that up to the inverter. One thing that I will make note of, if you have a Retreat caravan that is similar to this one and you're looking to do this conversion in it, the AC side of it connecting to the shore power is an absolute nightmare because the cables are fully encased in the walls, like absolutely 100%. There is zero access, and luckily there was 2 outputs coming from up here, which is the factory input. One we traced to the first point of it was there's a power point under here in there, and then the other one was a power point in the bed area. So what we actually had to do is we've run 2 outputs from the multi-plus and 1 input and 1 output to the power point over there to then grab the shore power from here, but then to also give power, output power back to that power point, which will then take it across to here and the TV and outside. And then on the other circuit, we had to run another output AC cable from under the bed to this power point in here, which then powered up the rest of this area and then all the kitchen section. So just be mindful if you do have a Retreat or you've got a van that comes out of the same factory as a Retreat and you want to do the full 3 kVA multi-plus and set it up, I highly recommend you get it done by a professional because it's not a normal setup. You're running more cables than usual and you're running them all external. Before I showed you the Victron Servo screen. Now this connected to Wi-Fi, connects to the VRM portal, so I can be on my phone, on my laptop, anywhere in the world, and I can see it in real time. The whole system setup, 98% here, 98% here, 6.7 amps, and we're drawing, there it is there, 6.6 amps. You do have to have the servo screen connected to Wi-Fi to do that, like just in your connectivity settings, and then you go into Wi-Fi. Now if you are connected to like a Starlink, turn the Starlink off and turn it on the next day, you do have to go through and do a reboot for it to actually continue to upload to the VRM. The internet connection just comes up with like an error, so you just got to reboot it and then make sure this is back on with the internet. Let's say it's a Starlink, and then the VRM will work again. Just something to note. Servo screen, now this one doesn't have any tanks or temps, purely just customer budget, but it leaves all the accessibility there to do it in the future if the customer wants to. Like obviously it's got the RV Electronics tank sensors up here, so he can always swap it. What I'm going to do now is do a bit of a pressure test. Now keeping in mind in some other videos when I've talked about batteries and amp hour rating and BMS rating, two completely different things. Amp hour rating, capacity, BMS rating is the strength of the battery, essentially. It's the strength of the BMS. BMS controls how much power you can actually draw from it. So we've got two 200s in here. They've both got a 200 amp BMS. When we're adding the second battery, we can only add half the BMS. So we've got a 300 amp discharge rate, essentially continuous discharge rate on this system, which I'm going to show you right now. So we are plugged into mains power, but I don't have it turned on. So let's just go to inverter only mode, to as if we were completely off the grid. All right, now we are inverting. So what I'm going to do is turn on the kettle, and you'll see we're pulling 180 odd amps, 2000 watts, but it's 2300 watts off the battery conversion losses. Now I'll also turn on the electric hot water system. Now we're pulling 2800 watts off the battery. It's actually 3600 watts, and it's 286 amps. Now this battery system will be able to sit there and cope with this, no worries. I'll show you now on the app the way that we've wired them up, again with the two batteries, wiring the first one with one active and one neutral, and then vice versa. So we've got 147, 45 amps coming off this battery. That was 4B, and this one is the other one. And we've got 146 amps coming off this one too. So literally perfect. You couldn't get any more perfect. And that is because we're running from active to one battery, neutral to the other battery, and then links in between. Ideally, you want those cables to the inverter like the exact same length, the active and neutral, which we do all the time, try and marry them up exactly as best as possible. But it also depends on the shunt placement and whatnot. But you'll see here, we're still easily pulling 290 amps off the battery system. Yes, it's at 12.5 volts, but that's perfectly normal. That's, to be honest, to be drawing 300 amps and be at 12.5 volts is really good. I've seen some batteries pull like 150 amps and drop straight down to 12.0 volts when they are completely full. That's lithium I'm talking about. Again, in real time, you can see it all on here. So let's say I turn the kettle off, you can see that wattage has already dropped straight down on both. Turn the electric hot water off, and now we're pulling 40 watts, okay? Now, what I'm gonna do here is show you assisting mode on the MultiPlus. So we're in inverter only. Lala will go to charger on mode, or inverter on, so we just look for shore power. In a second, it's gonna connect to our shore power. We just heard it click there. And now it's gonna start charging off mains. Now, again, we're only going to get the 120 amps of charge, and it's 1400 watts in, but it still leaves an allowable amount of power to pull from the grid that we're not tapping into. So again, I'll turn on the kettle, and I'll turn on the electric hot water. Now the inverter has turned into assisting mode. So because I've set the grid current limit to 10 amps for the grid, which is this reading here, because we are plugged into a 10 amp socket in the workshop, if you set that higher, to say 16 amps, you're just going to start tripping circuit breakers. So what we've got here is assisting mode, where we can only pull 10 amps here. We're pulling more than 10 amps essentially off at 240 off the inverter, which we can see again if we go into here. You'll see we're pulling 12.6, 12.7 amps. I don't know how well focused that was. There you go there. So the kettle's about to stop, but you see exactly what power coming from here going straight to here, and then the batteries are assisting the inverter by pulling the power. Now the kettle is stopped, and there again we're only pulling the 1000 watts, running the electric hot water, and the MultiPlus has gone back into charging mode because there is surplus energy coming from our 10 amps available from our 240 input. Now we are charging again at 65 amps. That right there, absolutely perfect example of why we use the MultiPlus and why they are so bloody good. Jump up on the roof now and I'll show you what we did with the solar on this van. So customer had two panels either side. They are actually these old ones here behind me. They were stated that they were 170 watt and they're meant to be putting out a VMP of 19.3 volts. I tested them, both of them, in the workshop with the light here, and they're both putting out 9 volts. One was 10.5, one was 9.5. As where these panels that are on it have a VMP of 19.5, I believe. Same conditions, exact same spot in the workshop, and they were putting out 16 volts. So I recommended the customer, these panels that you've got are not very good, old technology, and for the same size panel, you've gone from a 170 watt to a 225 watt. So we've added 3 to go 660 watts, or running through the 50 amp solar MPPT. Original brackets, and the new brackets for this one. So now they've gone from 2 times 170 watt panels that weren't in any sort of good condition, unfortunately, to now 660 watt system. We can't test the solar panels till they come in, so I sort of have to talk to the customer once I test them and go, look, we can do either option A or option B, and he went for option B. That way it'll actually give him an efficient setup, and the solar panels are all the exact same panel, so it's all going to run at 100% efficiency, which is, you can't ask for anything more than that. But yeah, thanks for watching. We'll see you on the next one. Thank you.